This is Professor Pelton. This is part one of chapter 3, section 1. So we're doing relations with domain and range and functions in these next couple of sections. This one specifically on relations and functions. So relation is just a mapping of inputs and outputs. You put something in, you get something out. That's all a relation is. Some relations are functions. Okay, but not all. But all functions are relations. So a relation is if you put in an input and you get exactly one output. For example, you go to the store and you buy something, right? If you buy 5 identical items, all 5 identical items should be the same price. If you get 5 different prices, that is not a function. Something went wrong, right? But if you put something in, you get a random output, and you could get 2 things in and you get the same thing out. That's not a function. That's just a relation, some kind of input to output type system. But if it actually corresponds correctly, like a store, when you put in items, you get a unique price to that item, then it is actually a function. Okay, so there's ways of representing data, and these are the various different ways throughout algebra in high school. And these are a finite set, so ordered pairs are given over here. So I can write them in the table, so -2 and 2, -2, -2, 0 and 1, and 3 and 1. There's no particular order to them. So if I do an input-output mapping, that's -2, 0, and 3, and the outputs are, let's see, 2, -2, and 1, right? So -2 maps to 2, -2 maps to -2, 0 maps to 1, and then 3 maps to 1. Okay, so the question of whether this is a function or not, the answer is no, because this input right here, this input of -2 has 2 outputs. So you get something and it has 2 different outputs. That's not, in fact, a function. So this is just a data set is just a relation essentially. Okay. So domain and range is similar to the input-output mapping. Again, you don't repeat the values. So the input values are -2, 0, and 3. And the range is -2, 1, and 2. Right? Or essentially the x and y values. Let's see. So if we graph these, we have -2, 2. We have -2, -2, and it'll be down here somewhere. I'm sorry, down there somewhere, right? Not there. Let me erase that one. And then what do we have here? 0, 1 will be right here. And then 3, 1, 1, 2, 3, and 1 will be right there essentially. Right? So what you're looking for is if you have a vertical line that has 2 points that are going to overlap, then you don't have a function essentially. You just have a relation. So essentially, what do we have? Relation, function, question mark. Yes, this is a relation. It maps the inputs to outputs. And we showed that various different ways, whether it's graphs, tables, or actual maps or coordinates. Okay, is it a function? No. The inputs map to more than one output, right? Each input can only map to one output, and we had one case where it mapped to 2 outputs, which cannot happen. There needs to be a guaranteed outcome for an input. Okay, pause the video, try a student problem for yourself. Okay, so a student problem, like a table of values with the points. So we have 2, 3, we have -1, 1, 1, 3, and -2, 3. Okay, so we put that in a mapping. We have 2, -1, 1, negative 2, and this maps to 1 and 3, right? So 2 maps to 3, negative 1 maps to 1. Oop, I did that wrong. I'm sorry, 2 maps to 3. What am I doing? I'm sorry, I said one thing, did another. Okay, positive 1 maps to 3, and negative 2 maps to 3. Okay, so each item has an expected output. This actually is a function, right? You can go to the store and buy 5 different candy bars that are all the same price. That's fine. Or you can buy 5 different cars of different colors. They're all the same price. That's fine, right? So there's each input doesn't have more than one output. They have this. We have several inputs of the same output, but that's fine. Still a function though. So the domain is my inputs. So that's negative 2, negative 1, 1, 2. And my outputs are 1 and 3. Okay, and you can graph those. We'll have to move this up a little bit to do that. Oops. Okay, come on screen. All right, 2, 3. I think it was what? Negative 1, 1, 1, 3, 1, 2, 3, and negative 2, 3. Right, and you notice no vertical lines actually intersect. So that's fine. So in this case, is it a relation? Yes, it is a relation because the inputs map to outputs. Yes, it is a relation that maps inputs to outputs. Okay, so some relations are functions, but not all functions are, I'm sorry, some relations are functions and all functions are relations. So it also, in this case, is a function. So yes, because the inputs have exactly one output. Okay. If you put something in, you should know what you get out. You don't get 2 different things out when you plug it in. Okay. So we can look at these data sets and decide for ourselves whether these mappings or relations. So if something's a mapping, it's also a relation by definition. So these are all relations by definitions. So the question is, are they a function or not? So if I look here, this fails because if I plug in a 1, I get 2 different outputs. So not a function, right? Fails the definition. Every input has this. These ones are fine. Each input has 1 output, but the middle input has 2 outputs. That's not a function. So this one is a function, right? And you're asking yourself, well, wait a minute. I have 2 things going to negative 4. That's fine. I can get 2 things that go to the same output, but each input only has 1 output. So the 2 only has an output of negative 4, and the 4 has an output of negative 4. So they only have 1 output. All right, pause the video. Try student problems for yourself. Okay, so student problems. The first one is a function, right? Every input has 1 output. The second one, this 1 has 2 outputs, right? So this is not a function. You look at this one, you're like, I'll go to negative 4. This must fail. But no, you can draw this out as a mapping if you want to, right? Negative 1, I'm sorry, negative 2, negative 1, 0, 1, and 3. And they all go to 4, right? So every input has exactly 1 output. The output just happens to always be 4. So this is a function that actually works fine. Okay, that's the end of part 1.